here's your homework problem. We've done a lot of problems like this. This one is kind of special because it's all variables, no numbers involved at all. And there's some things we need to pay attention to here. Smooth tabletop. They mean frictionless, even though they didn't say it there. That's what that means. So we're going to neglect friction. And what we're doing is FBD N to L. And the reason why we know to do that is because we want to determine the acceleration, and we're dealing with lots of forces. So what I recommend doing is trying A on your own, pausing the video, doing that right now, then checking your work. Or if you've already tried it, just fast forward to the end and see if you're right, and you don't have to watch the video. So I'm going to do this all the way out, and we'll do all the steps here. Okay, so I've got these two m's, and each of mass m means they are the same mass. Okay, we've got this rope and different lengths and stuff. These lengths will not become important until we get down here. Alright, for part A, I don't care about those. Here's the other important thing. Hopefully you've read this a couple times already. I recommend reading it like 3 times to make sure you understand it. Your end answer to every single part on here has to be in terms of h, m, and g. Those are the only things you can have in your answer. Alright, so let's check it out. Let's do the FBD part first. So here's mass A, here's mass B. And for mass A, I've got its weight, and I'm going to call it mg. Got normal force, and I've got tension pulling it along. Now notice I don't have to put ma, and that's because the two masses are equal, which means I don't really need to distinguish between them. Alright, for this one over here, I've got mg, and upward I've got tension. And mg is going to be bigger than tension because this thing is going to accelerate downward. Because there's no friction holding this back, we know it is going to accelerate. We don't have to check static friction and all that. From these I'm going to write F net expressions. So I'm going to shortcut a little bit and just start by saying ma. Okay, and I'll put F net over here. F net equals ma, and this I'm going to start for mass A. Then over here I'll do mass B. Okay, now the only force that is unbalanced for mass A is tension. So normal and mg cancel out. So this right here is my final expression. That's pretty simple. For this one I'm going to say F net is also equal to ma and is equal to mg minus tension. So here mg is our driving force, tension is opposing it. Let's switch colors. Okay, these two equations right here I can combine to get an expression for acceleration. Now that has acceleration in it, so why can't I just rearrange this for A and call it good? The reason why is because all answers must be in these terms. Alright, let's combine. So I've got ma plus ma is equal to tension plus mg minus tension. I simply added the left sides and added the right sides. Tensions go away because I got a negative one and a positive one. Those cancel out. Okay? If I add these together, I don't have to factor like I do a lot of times when the masses are different. All I have to do is say 2 MAs is equal to mg. And then also very conveniently, in this situation, the m's are going to cancel. So I have 2a equals g, or acceleration equals gravity over 2. So this thing is going to accelerate at half little g. And we're not going to shorten this to 9.8 or to 4.9. And the reason why is because they want algebraic answers in these terms. So after every part here, I want you to check your work. Make sure your answer has only got these 3 things in it. And you can also use numbers as well. Okay, we just won't have numbers to plug in. So we can have a 4 in our answer. Alright, but we don't actually know what h is and we can't plug it in. So what else can I tell you? Block B strikes the floor and does not bounce. Determine the time at which block B strikes the floor. Here you need to use some kinematics. Use one of your kinematic equations, and you know acceleration now. So in your kinematic equations, when you have A, notice A is not on our list here. So you're going to sub that in for A somewhere. Alright, here they want us to describe the motion. This is going to be written. Okay, we're not going to do math here. Part D, describe what's happening. Part E, determine the distance. Here you are going to need to do some algebra, just like we did in part A. Alright, now this problem, I think this problem's easier. I'm not really going to start it for you, okay? But I do want you to look carefully. Look at this. Case 1. The mu's are the same. The masses are the same. This force is 50 newtons. If I do 5 times 9.8, this force, well, let's see. We can use 9.8, but we could also use 10. So if I do 5 times 10, that's 50 newtons for mg. So what's the difference? I've got 50 newtons here and 50 newtons here. This is like a force applied. This is an mg. At first glance, it might look like there's no difference, but there is a big difference. I want you to try and figure out what it is. Alright, so I think you can rock both of these problems out from there, and hopefully that helped get you a good start on your homework. So please come in with these completely finished, and we will go over them as we start to review for your test. Thanks for watching.